Thank you for joining us this evening. My name is Kristen O'Hara. I'm the Director of Programs here with Pajarito Environmental Education Center. We are joined by Gary Goddard, who will be giving a presentation about home energy management. We are, of course, Pajarito Environmental Education Center is located in Los Alamos, New Mexico. I will be your friendly moderator for tonight's program. PEEC is a nonprofit organization that operates the Los Alamos Nature Center. Visit our website, peaknature.org, to learn more about us and about memberships and all these amazing things that we do. I want to take a moment to acknowledge our wonderful members and donors for your generous support. For details about becoming a member, donor, or volunteer, again, visit our website. Just a few logistics before we get started. This is a hybrid program, so our presenter will be taking questions via Zoom chat and from our in-person audience. For those of you watching from home, you can find the chat feature on the Zoom app menu bar and type your question to the moderator, that's me, Kristen, into that chat, and I will relay them to Gary at the end of his presentation. Please remember that not everyone in the room here has a microphone. So there may be a delay when we are listening to questions in the live audience. Don't worry, we'll get back in a second and try to relay our questions as best as possible for everyone on Zoom. Of course, after this talk, you will receive a short evaluation in your email. Please take a moment to fill that out. Your input helps us improve future programs. All right, so now for a bit about our presenters. We are joined tonight by Gary Goddard, our new Los Alamos County Airport Manager. Has spent his career at the intersection of design, technology, and sustainability. With a background spanning architecture, teaching, and building automation at Los Alamos National Laboratory. He specializes in high performance buildings, energy conservation, and optimizing control settings. Living off grid along the Rio Grande, Gary combines professional expertise with a personal commitment to sustainable living. He is also joined by Abby Hayward, who is the Water and Energy Conservation Coordinator for the Department of Public Utilities. She is tasked with education and outreach for customers interested in increasing efficiency and conserving resources. I'm going to give it over now to both our presenters and we can get started.
Oh, it's right there. Okay. Sorry about that. We had kind of an issue getting notes. Um, so anyway, uh, okay. So I put this picture on here because this is not where I live, but it is kind of a little it's something I built recently and had an extra solar panel, so it's a little microcosm of off-grid living, or at least off-grid bathroom. So, but yeah, I worked at Lano for about 14 years with building automation and controls, and worked together with a sustainability program, and so the control stuff that I'm going to talk to you about tonight doesn't really have much to do with that. It's more about my experience in running an off-grid property, and the kind of visibility and control I needed to do that. And so been living off grid for about with my wife and my son, and we have a bunch of goats and chickens and dogs and stuff, and about 6 acres on the Rio Grande, near Alcalde, down in the valley. So, but it's been an evolution, and the need for having to control devices and control power loads to from the batteries, depending on, their state of charge and all that stuff, is relevant to the talk today that we're having, because the county is going to, next year, move into time of use and demand charge, rate charges. And so the same kind of stuff that I had to learn to control my loads would be helpful, also to residents that are wanting to, optimize time of use charging. So that's the nature of my talk today. So I haven't really ever talked about the stuff that I'm going to talk about tonight. So we'll see. Uh, I might be a little overkill. What I needed for off-grid managing my system is probably a little overkill for what you need to just shift some loads for time of use. So I'm going to let Abby talk about the county and the time of use rate charges.
Zoom, we're gonna pause for technical problems for a second. Should be talking about IT instead. Oh, I got notes. All right. Well, I'll do some background explanation while Kristen saves the day with the lovely graphics we made. All right. I'm going to read some notes that we have available on our DPU website as well, just so the messaging stays the same and I don't confuse anybody. As Gary mentioned, the time of use and demand rates will go into effect no sooner than July 1st. They need to work out the new software that will enable that to be functional. So time of use rates will help the utility provider, your DPU, to better align the costs that electricity consumers see with the actual cost of producing that electricity. The cost of electricity changes throughout the day, so we're getting it cheaper when the sun is out and it's more expensive when the sun goes down. With higher costs at home when the customers are using more of the electricity, which occurs in what we are calling peak hours. And this was, aha. And we did have a study was completed to show that our peak hours are between 5 p.m. and 11 p.m. So let me see if I can use this cursor. So there's the on-peak hours for the Zoom folks as well. The demand charge, which is also coming with time of use, is intended and designed to fairly allocate the cost of providing energy based on a customer's demands from the electricity distribution. So in this little chart over here, you can see that all of these little lightning bolts would represent like if you turned on your stove and you ran a load of laundry and you put the dishwasher on all at the same time. Appliance stacking per se. So a customer who uses a lot of energy all at once demands more energy at that point in time. Customers whose energy is spread across the day, such as maybe in this bottom example where you can see it's kind of shifted across the time period, uh, would demand less. So more demand equates to higher costs for the utility in terms of grid maintenance and power purchases. Think of it like wear and tear in our system. The collective demand of the community, including LANL, is what the system capacity needs to be designed for to avoid curtailment or blackouts. Lower peak demand means lowering the overall cost of the system, thus lower rates for the consumer. So the demand rate is applied to the single highest amount of electricity a customer uses or demands during that single hour in the billing period. So again, you can see where that appliance stacking peak is, would also be the demand. However, I will tell you demand charge is not dependent on peak or on off peak or on peak hours. It's just whenever you're using the most amount of your load. Like time of use charges, a customer has the power to reduce their demand charge by shifting this usage. You can find more information. We don't want to spend a lot of time on this tonight. The talk is more about the tools available to help shift that demand. But you can find all of the information at that website at the bottom, ladpu.com/TOU. I'm going to give it back to Gary without touching anything.
Okay. So I think the key takeaways there is that the price is going to change, and some, the off-peak time is going to be less than what you're currently spending. I think right now. So I don't have an electricity bill, but I think you guys pay about 14 or 15 cents per kilowatt hour right now, no matter what time it is. Thank you. 14.2. So so that means, if you shift your loads to off-peak time, you'll actually be paying less for your electricity than you are now. Obviously, it's going to be pretty hard to shift all of that. You can see on that shifted load use where it says between 11 to 4, or 11 to 5, where it's kind of a flat line. That's generally considered your base load, and that is usually pretty standard, and that goes through the night, and so you probably won't be able to shift that load, but everything else may be flexible. So the biggest load that we have these days, if you have an electric car, is your EV charging, and that's a really easy one to shift to 11 p.m. Instead of getting home, plugging it in, and it just starts charging, you have some way of shifting that load, or schedule the app that comes with your charger, or your Google Home or whatever you use to shift that load. If you shift it from 11 p.m. till the next day you need to go to work, it'll probably be full, and you'll be paying that 11 cents per kilowatt hour rather than the 14.2. And other ones, water heating. If you have a electric resistance here, those are pretty heavy duty, heavy loads. If you have a heat pump water here, that's about a third of the electric resistance load, but it's still significant. Laundry, another one that's really easy to shift unless you sleep right next to the laundry room. Um, Dishwasher, those usually have built-in timers on them. HVAC, that's a little harder. But one thing you could do is, during the peak hours, you could shift the set point up a little bit, so you're not either cooling as much or heating as much during that from 5 to 11. And then battery systems, I don't know how many people here actually have a battery system as a backup of their house, maybe part of a solar system or just a backup for a power outage. But, again, you would charge that system after 11 p.m. So these are some of the tools, and I use all of these, including Christmas tree timers like this one on the top. They're great, simple solutions. There's really great things about them in that they just work out of the box. You don't have to read a manual. You have to pull those stupid tabs up to get them to work. But besides that, they're pretty good. However, they're not going to shift your EV charger. You can't plug your EV charger into something like that. I mean, I think you're limited to about 15 amps or so, which is pretty.
I do.
So those are really good for shifting small things. Mid-range are smart strips that you can control, sometimes with an app, sometimes with Alexa, things like that. But again, these are all just normal AC loads, and 120 volt, 15 amp AC loads, and they're pretty small. And then there's advanced platforms like Home Assistant. I'll talk about that later in the talk. Google Home and HomeKit platforms, and they generally turn off and on your smart switches, which are the smart plugs over to the right side there. And I use quite a lot of those as well, to turn on a pump here, to turn on lights, things like that. More just for automation purposes rather than load shifting. Although, I do have some things that are quite a few amps and still can affect my battery storage. So still good things to shift if you can. So one of the things that I use, and it took me a while to figure this out, and the technology became mature, or at least more mature, just in the last few years. And this is a Sense Energy Monitor, and this really has helped me a lot in monitoring what's going on in my house. And it was very easy to install. The previous generation energy monitors, you need a current transducer on every one of these black wires in this main panel that you see here in the picture. So you'd have to put a current transducer on all of these. It kind of tends to be a little bit more problematic and dangerous to install yourself when you're doing all that. There's ways to shut the whole system down and then do it. But when you get into doing that, usually end up hiring an electrician. But this one, you just clamp on these. These are the two 120 legs that come into the house. And then it uses a high frequency spectrum analysis to understand what your devices are. So it's basically sampling your electricity waveforms, the frequency and the and the amplitude um, every whatever a few hundredths of a second. And so it starts to map out like what a refrigerator looks like. So usually a refrigerator looks like it's got a big startup current, and then it flattens out, and then it drops down, and then so a lot of induction motors all have that kind of frequency. So using machine learning and community source databases, they can map that, and they can figure out, oh, this is your refrigerator, oh, this is your freezer, this is your um, heat pump. This is, they can figure out a lot of this is an electric light, because it's just a steady resistive load. So every device in your house has a different signature, and this was really cool about this. It just didn't take a lot of infrastructure. It's like $350. You put it on. I put it on myself. Maybe you want an electrician, maybe you don't, but it's fairly simple and fairly safe to put in. And then it takes time for it to figure out what the signature of your devices are. But once it does that, and it's not flawless, there's a lot of devices that kind of look like other devices, have signatures that are similar, and so it doesn't quite get a lot of stuff right. But it usually gets the heavy hitters. It'll recognize an EV charger. Yes. 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 It'll talk to Home Assistant and Google Home, and I think it'll pretty much do most of the larger platforms. Well, I'll get into that. It doesn't matter. Oh, Matter is the communication protocol? No, it's just Wi-Fi. Yeah. You might be able to get a Zigbee version, but anyway, so back to, so it's not perfect, but it'll capture your biggest devices, and there's an app that goes on your phone, and it shows you which devices are running when, and then I'll show it live in a few minutes, but it's been really helpful to me to be able to think like, why is my system using so much energy right now, and I can pull it up and say, oh, it's the well pump has been running for the last 2 hours. I must have left something on, or there's a leak or something. So it's been really helpful for me in just understanding what my loads are.
That's okay.
It doesn't control your loads, but it gives you, it's a monitor that shows you how, what's running.
Can I?
So this is the other tool that I use, is called Home Assistant. And I had used Alexa, super annoying if you ask me. And and I've used some of the Google stuff, but I just wasn't really happy with all that. And so I stumbled upon this Home Assistant. I mean, this is an open source software. You usually need it to run on a server at your house, so you can buy a little Raspberry Pi version of it, or you can buy a small server from them that's called Home Assistant Green server, and it runs all the time, because to monitor all this stuff, you don't want to have your home laptop open and running all the time. So it's a little server that connects to your network, and it will connect to just about every smart device that you could buy. So that's what I really liked about it. It wasn't this ecosystem, and it had to be Google, or it had to be Nest, or it had to be one of these things. It just, if it was Wi-Fi, Zigbee is another protocol that's a radio frequency protocol that's used often in home automation. And there's a few other ones, Z-Wave and Matter and things like that. So
Sorry, Gary.
you can go to the store and just buy a smart switch, and you're, probably 90% likely to be able to integrate it into this system. Whereas with Google and the other HomeKit and things, that's not necessarily the case. They've partnered with other people. This is open source software. It's run by a company in Europe, and it's they're always improving it. It doesn't cost much, They're not trying to figure out how to get more money out of you. So to me, to me, it was a lot. It was a big breath of fresh air. It can be a little bit more complicated if you want to do more sophisticated things, and I'll get into that in a minute. But what I really liked about this is this part about universal integration, um, and then you can also connect with things. So I was able to connect Sense to it. It brought in all the monitor data that Sense was getting. And then my solar system, I was able to pull in all the Modbus data from the solar system so I could see, what the solar panels were producing, and all the statistics around my solar and battery state of charge, which was really important for what I was doing to manage. So, and these are some simple automation strategies you can use. Like I said, some of these you can use with the Christmas tree timer, and some of them you can do with the smart switch, and some of them probably need more home automation to be able to trigger stuff. So, simple time schedules, those usually exist on the dishwasher, on a heat pump, water heater. Probably not on an electric resistance hot water heater. You would have to have some kind of interface to switch that. Conditional logic, these are just basic things in home automation, and I'm going to keep on referring back to the control strategies that I needed, which was all around my battery charging, but it could be, similarly applied to peak hours. If it's peak time, don't charge your EV, after 11 p.m. If it's not peak time, charge your EV. So I was doing things like, if the batteries are full, then allow my EV to charge. If I prematurely charge my EV, that could drain my batteries really quickly, and then the sun goes down and I don't have any resources anymore, and I got to fire up a generator to, get through the evening. So those it was particularly important in my case. Yeah, down at the bottom, there's a picture there of the Home Assistant Green server, which is the one that I use. Um, so yeah, and there's a little tip on the bottom, and I learned this through trial and error, is how we create automations, and then I had no way of shutting it off, but firing up my computer, getting into the server, figuring out where it was, and then shutting it down. So now I've built dashboards that I always have switches where I can just go and tap them and switch them off, whether it's on my phone or on a dashboard at home. I have a little tablet in the house that shows all this stuff, and I can, punch it. And I'm like, oh, it shouldn't be charging right now. A short story. I was just up in Colorado with my family over the Thanksgiving weekend, and before I left, I was cleaned out this pond. I have a solar room on one of the sides, this south facing, and I have this pond in there. It's like 500 gallons, and I got this little heater in, and I'm like, oh, I'll be gone. I'll have plenty of solar resources for the pond heater to keep the temperature up a little bit, and it helps heat up the shop and the guest house. And I didn't plug it into a smart switch. I just plugged it into the wall. And while I was in Colorado, I'm pulling up my phone going, oh my God, we're like 10% of my battery. And it's, and I'm like, oh, I just need to shut off that pond heater. And I realized that I had plugged it into the wall instead of plugged it into a smart switch, and I had no way of shutting it off. So, it was like, I was stressed like the whole weekend, a little bit, just because like it was cloudy, and I'm like, oh man, am I going to drain the batteries all the way down to zero? And then, it was just like kind of a mess. So I'm like, oh, I got to plug things into a smart switch, and I got to have a button on my dashboard, 30 kilowatt hours. So, so I was going to do, let's see if I can get this to work. Cinch dashboard. I'm going to try to connect to, perfect. So this is my system. This is the Sense Energy app, and this is live. We're running at 500 watts, and you can see on the left column it basically gives you a rundown of all the events and I can click on one of those events and it'll bring me to the well pump and what's happening with the well pump and how often did it go off, and its history. So it'll give me the timeline and I can go, I can dig deeper into that. Oh, is the well pump, going off too often? Did I leave it, the sprinklers running, or is there a leak in my house or something like that? So I can drill down into these things and find more information. Um, the dashboard, if I look at the usage details, so it's the first of the month, so not much data here. But it'll give me the data, the electrical data, just like your electrical bill. You can go into the Census Energy app, right? For that, that's what you guys use, and you can look at your data. This is similar, but it's in real time, and I can drill down, day and month. But if I want really even higher resolution, like if I was sitting in Colorado worried about my electricity and worrying about the loads, I can come over and I can look at this and I can say, what happened for the last day? And it'll load all the data. And this is pretty high resolution. This is within maybe 20, 30 seconds. I mean, it changes the time series as I move through it. But you can see, remember how I mentioned how a refrigerator starts up, it's got a high peak load, and then it levels off, and that's what we're looking at there. So, but you can move through it. So one thing that doesn't do is I can't click on this and tell me what device that is, which is really unfortunate. But I know it's kind of a high inductive load because of that particular shape and the wattage. So that's actually the pond heater. But in any case, so I can come through and I can scan through and find out what happened at night. And you can see right here, this is my base load. It's like 400 watts or so. That's not terrible. It's not super great. But and then something happened here. That's probably the pond heater freaking out. Anyway, it would be nice if I could drill down and figure out what that was. I mean, I can do it. I can back it out. I can look at the time and then go look at the devices and figure it out. But it's interesting, it's really gets you in, much more in touch with what's going on energy-wise in your house. Now, if you're trying to, try to figure out what you're using, what is already set up to run between that peak time, you could come through here and kind of look at these devices, and then you can go to your device tab here, and here's all the objects that Sense has identified. Some of them I have to go in and rename because they're wrong, and then some of them are just ambiguous. You don't really know what they are, and I don't really care that much. Like there's a bunch of these kind of things. But I could go in here and I could say my clothes dryer, and I could look at the timeline. You just scroll down and you look at the timeline, and I could figure out, when the clothes dryer was running, and maybe I should program it, right here it was running during peak hours, and so maybe I should program it to run outside of peak hours if I want to save 4 cents a kilowatt hour, 8 cents a kilowatt hour. You can check out your electric vehicle and see what. So it's a really helpful app. And you can get in there and rename stuff, and you can configure it. There's a, like I said, it's not perfect. It doesn't identify everything, but it does a pretty good job at, if it knows when I'm vacuuming. So that's pretty cool too. You can also go in here and, figure out what happened during the day while you were gone and what your family was up to. So oh, I find all kinds of stuff running. So one of the things I found once was that I had this phantom load, and it was 400 watts, and I could not figure it out what it was, and the Sense couldn't identify it. But I was looking at the waveforms and everything, and I was seeing like it was basically steady all the time, and it started like in, this was a few years ago. It started in maybe September, and it went through, October, and it was 400 watts, and it was draining my batteries pretty good. And it turned out I was able to go in and shut down all the circuits and kind of zero in on what it was. And it was the cabling that went to the remote pump, well pump. And so the insulation was probably nicked and it was probably shorting out in the wet environment of being 4 feet under the ground. And so I had to trench up and redo the whole wiring for it. But it was this phantom load that I needed to track down because it was draining my batteries and it was a problem. So, but this definitely helped me look at the waveforms in a lot higher resolution than you're ever going to get from your utility provider. So that's something to consider. All right, so I'm going to move into Home Assistant. Let's pull up the dashboard that I got here. So right now you can, this is my main dashboard. I have a little tablet that sits in the living room and shows me this data. And it gives me the battery state of charge, which is the most important thing. PV panel power production is the second most important, and system load is pretty important as well. And then it tells me my total production for the day and how much energy I've used today. And then it's connected to a bunch of smart sensors like temperature sensors and things like that. So it just gives me good data, which is outdoor air temperature and the temperature of different places on the property. And then it comes from a sensor that's outside on the sort of at the furthest edge of the deck. So oh, yeah. So the question was, where did the outdoor temperature come from? And was it a part of is it coming from Sense? And this one is not coming from Sense. Sense only does electrical equipment power usage. It's not really a home automation platform. It's just energy monitoring. So the temperature, I have a bunch of Zigbee temperatures, the little temperature modules with a small battery in them, and I have them scattered everywhere around the property and the house and the bedrooms and the kitchen and the shop and the solar room and everything. So that's where that's coming from. So this is a little Zigbee sensor that I connected Home Assistant to the Zigbee sensor and then built the dashboard. You can edit this dashboard by just pulling in various entities from different devices. So that's what it is. So this page is like my living room page, and then I have another page for my guest house. It also scrapes some USGS data from a website that tells me what the Rio Grande flow at Embudo is, which is really helpful if I want to go down to the river. I know, or the river surges, and it's like a good time to go kayaking. It's obviously not a good time to go swimming at 41 degrees, but anyway, it's cool, interesting data. I put that up in the guest house because sometimes we have guest people who might want to reference that kind of information. Same thing for the weather station information. I was able to pull in through a REST API connection, which was pretty easy to pull in the data from the closest weather station that I have to my house. Instead of putting up a weather station myself, I just pull in the data and put it on my dashboard. And then this one is pretty undeveloped, but this is a little bit more information. These are information from different inverters and charge controllers of the system. And these are just big lobes. I haven't really developed that. This is like more connections to the weather station. So that's the dashboards. That's mainly what I use to display everything. I'm going to, I got the solar room dashboard as well. Show that real quick. Yikes. Anyway, there's a picture of the solar room, but it's got a bunch of data that my biggest thing with the solar room, since I'm growing plants in there, is not to let it freeze at night. So that's why I have a pond in there with a bunch of thermal mass, and then it circulates air into the shop and back and stuff to keep it from freezing. There's an energy app here, which is really cool, except that I can't use most of these things because I'm on propane. I don't have utility bills that I can feed into here. My electricity uses I can because that comes from the Sense app. But if you go here, so this is for those of you who, oops, what did I just do? Oh, okay. Sorry. Um, so if you go into energy configuration, there's a bunch of different things you can connect. So you could connect your gas bill, your water bill, your electricity bill, and it would all show up on that energy app. And so that's really handy. I mean, it's important to keep track of your water usage too and look for leaks. And the nice thing about Home Assistant is that you can set up a notification. You can say, hey, for me, if my pump runs more than 6 times an hour, I probably have a leak or I forgot about, a sprinkler that I left on. You can set up, other ones on your, from your water bill data. If you're using a high abnormal amount of water for X amount of days, then give you a notification, and it'll push a notification to your phone or send you an email or however you want to receive that kind of information. So, what time is it? 7:36. So I just come in here real quick and I'll show you, these are all the things that I have integrated in it. If you click down here, add integration, there's just a million different things. This is just A's, right? So these are all products that are out there that they've built connectors to be able to pull in the data from these different connectors. And I mean, you can probably pull in data from the New York Times. So but there's ambient weather network is where I'm pulling in the local weather station. Um, Bluetooth devices, I have a few of those. Forecast Solar is a really interesting one that I use. You enter a bunch of information about your solar system, and it will forecast how many kilowatt hours you'll get for the next um, day, tomorrow, week, month, and it uses a bunch of weather data to figure out what the solar radiation is going to be and how that would affect your system. So I've set that up, and it'll tell me, and I have automations where if the tomorrow's forecast is going to be low, then don't charge certain, I mean, don't use certain loads and keep the load use to a minimum. So I find that a really handy one. Um, I have a propane sensor that actually senses the amount of propane in the tank using an ultrasonic sensor and sends that data to Home Assistant as well, so that I don't have to go read the analog dial on my propane tank all the time. Heat pumps, there's a Gree heat pump there, mini split, and that's also controlled and makes some decisions based on battery state of charge. And then Zigbee is kind of the platform that I've chosen. I've got, just a ton of different Zigbee devices, mostly sensors and temperature sensors and smart switches. And then I have electric car charger, which also does only charges when after the house batteries have been full. And then there's the Sense Energy app you can see, and then there's Modbus, which is where I get all my solar data from, and then the RESTful integration, which is other websites that I can pull data off of. So the other thing I wanted to just give you a brief uh, introduction to was automations. And so this is these automations are really simple. They have these simple interfaces where you just you go through and you can configure it by going through a drop down and selecting your entities, which is, um, there's a lot of Sense pulled in everything it had, so it's like 100 different things. But you can select your entity and you can do if-then statements really easy, but just by selecting what the conditions will be, if the indoor air temperature is above 75 degrees and the battery state of charge is high, then turn on the swamp cooler. So you can cascade these things. You can do them with these kind of if-then statements that are built into Home Assistants, which is really cool. Or if you like programming, you can go into this markup language. It's called YAML, yet another markup language, and it's fairly simple. But the thing that I actually do, I used to a couple of years ago, I used to write these myself, and it was kind of difficult because it's not a language that I was familiar with. But now you can actually tell ChatGPT to write a write a YAML script to turn on your swamp cooler after, the temperature in the room is over 75 degrees. And it might not run out of the box, but it'll help you troubleshoot it as well. And it'll get you pretty close and you can just tweak a few things. And then, so it's been really helpful to do it that way. I've gotten a lot more sophisticated control because I didn't want to just, I knew I could probably make it work, but it was a lot of pain and suffering to get there. So writing the code yourself. But the built-in drop-down menus are fairly easy, especially for basic scheduling stuff that you would need for load shifting. Um, and then one more cool thing that I utilize quite a bit in here is this function called a helper. And it's basically a variable that you create that you can put on a dashboard. So I have lights off time. So the lights shut off around the property at 9:30, but it's on my dashboard. So I can come in here and I could change it to, whatever I want really quickly. And then it just says, if lights off time is true, then shut your lights off. So it's really easy. You can pull these. There's kind of these breakout variables that you can use that you can configure on the fly as needed. So, for time of use, you could say peak time, and then make a clock here. And then if the DPU decided to change when peak time was, then you just go in there and reset it to something different. So instead of going into your YAML program and trying to figure out which line that's on. So there's a bunch of other features in here. I don't use a lot of stuff here. People get really obsessed with this. They get really obsessed with 3D versions of their floor plan layout and putting all the sensors in the right place and stuff like that. I kind of just stick to the basics and what I need for my control. But it's a fun platform. It's not that complicated, and it's fairly inexpensive to run. It basically just cost me the price of the server, about $120, and then all the, the smart devices you could buy. I mean, they get you there. So that's pretty much what I got. I can go back to I had a few slides that wrapped up the presentation, but I can cover whatever you guys want to talk about in the last few minutes. So, um, I just, keeping this focus on the county time of use rate structure that they're imposing, there's a lot of stuff that you can shift really easily, and you'd probably save a decent amount of money. I figured it was about, if you charged your electric car 20 times a month and you shifted the use away from the 14, the peak time, like when you got home from work and you plugged it in and it charged to charging after 11, you'd save probably $500 to $1,000 a year doing that. So that's just an example. I mean, that's a pretty heavy load. So all the other examples would probably be less than that, but it's a fair amount of money. So one more. So yes, so I will take questions if you guys want to talk about time of use, load shifting, the tools. And then if you have questions about my own system, sure, I'm happy
We
to
do have
answer
a
them.
question online, if I may. She's been holding for a minute, so
Yes.
that's why I just jumped in. So I've got a PV system and wonder where to turn to learn about battery backup options. The power in White Rock has been very reliable, so there hasn't been a lot of incentive to pursue it. Do you have any comment on that?
Yeah, for someone who didn't really have much choice of being off grid or not, I, w- you know, I would buy a kerosene lantern and not worry about it. That's what I would do. But if you really need, if you really need a battery backup system, there's some really good um, lithium battery systems that have onboard battery management systems that really take care of the batteries for you and don't overcharge them or undercharge them. You don't have to do a lot of work. And for a resident who's grid tied, I mean, they're basically going to sit on the wall and do nothing until that moment when the power goes out, and then they're going to go through an inverter and source your house for however, probably easily as long as the power is going to be out And then, when the grid returns, they're going to charge themselves up again, and you're not really going to have to do much. They're very plug and play and very easy to work with. So that's, a little bit of research online will do you pretty good. I have a 30 kilowatt hour battery system, and that's kind of small-ish for like if it's cloudy for 2 days, I got to fire up a generator, but only for a couple hours, and then I'm full again. So it's not too bad. But for just a battery backup, you look at your bill, how many kilowatt hours do you use in a day? You know, are you really going to use that much if your power goes out? You know, maybe 14 kilowatt hour backup is plenty for you. Yes. Yeah. I mean, that's a good point. I think you'd have to really seriously dig into the numbers to come up with an ROI that makes sense on that. I mean, batteries have gotten a lot cheaper these days, and but you're still going to be paying a few $1,000s, and if you're talking, so you just have to count up your kilowatt hours and see if that actually makes sense. Is that actually going to save you money over the life of the battery? I mean, these batteries are good for whatever 8,000, 10,000 cycles, so you can figure out the math of all that. Sounds like another good job for ChatGPT. But yes, I think that's an Abby. Yeah, so the question was, is the time and use charge rate going to change throughout the seasons? And the answer is no. At this point, DPU is going to keep it from the 5 p.m. to 11 p.m. I think probably does shift a little bit. I mean, obviously when the time changes, that shifts, but I think it's just simpler for DPU to keep it that way. So that might change in the future, and then you'd get out your helper on Home Assistant and change it. Any other questions? 7 kilowatts of panels. Schneider Electric. So I have yeah, they have a little device that converts everything, the local CAN bus to Modbus, so that you can see it. I mean, there's a web application that you can. There's a little web server that will connect to your system, and you can log into that locally. But more importantly, you can push stuff out to the web and be able to see yourself on the cloud. So if I'm at work, I can log into it and see what the system's doing. But I don't do that anymore, since now that I have all the information that I need on Home Assistant, I don't really bother with any of that. Ah, his question was, what kind of solar system, or what capacity solar system do I have? And the answer was 7 kilowatts. And the other question was, what kind of inverters do I use? And I use Schneider Electric um, inverters and charge controllers, basically a Schneider Electric ecosystem. And the reason for that was that I installed the system 15 years ago, and there's a lot more economical versions or brands that have come out since then. China has really ramped up its production of solar panels and inverters and charge controllers, and they are really easy to work with and probably just as reliable. Although I haven't really had any problems in 15 years, which is really great. But it was quite expensive at the time. It's kind of top of the line equipment. Yes, in the back. Okay, so I have not had that actual particular problem. So the question is, uh, have I had any issues with a high startup load? This is demand, right? We're talking about peak demand, and having that affect other devices in my house, particularly other smart devices. Yeah, yeah. Well. So to repeat that, he's saying that if you had a high startup current device, such as like a resistive load that starts up at 19 amps, and you have a reset module. Uh-huh. hmm Well, I haven't, but I have used things like soft starts. For because I have a wood shop and I have a table saw and a dust collector, and those things have really high current startup loads, and they can affect my system. Already, it's a 220 load. Some of them are three phase, and they can create some pretty big jumps, and they've caused all kinds of havoc on my system. Sometimes my batteries can't source that high of a load. But so I've used what's called a soft start, and basically it's just a giant capacitive load, and it'll smooth out that high peak. It starts it up slower, and it doesn't peak as high. But they're kind of expensive. They're kind of messy. They don't always work. But I have used those. So I don't know if that answers your question, but you can find them online for 220 and 120 volt systems, whatever it is. No, I have the question was, is my inverter supplying three phase? And no, I actually have for my shop, I have a three phase rotary converter that uses 220, and it'll create a second phase using an induction motor, and it'll create another phase for the I have a jointer and a planer that use that. So yeah, those are pretty high loads. They're pretty smooth. They're not like my problem is my table saw, because that's starting with it's got like a high inertia to start up, and so you get quite a peak. Same thing, like air compressors. They have a lot of resistance in the pistons, and so you get very high load to overcome that friction in this, and that's when you get these really high peaks. Um, and I've had problems with my batteries shutting down because of that, because they say they can take the load, but I can't actually capture what that instantaneous, really high peak load that TPU would charge you for. I couldn't capture that, so I don't really know what that high load is. And so I've had to do some clever things around that, and I've also had used high current switching relays sometimes for those as well. So anyway, it's been kind of an issue, because just like DPU, this is a really good example, because my house is its own utility, right? So I have to build all my equipment for that peak load, whatever that is. Like everything I make has to be able to handle that peak load. So if I can, and that's what I'm trying to do with that soft start, is trying to shave off that peak and invert it a little bit, so I don't have to get a whole new, I don't have to spend $10,000 on an inverter. I only have to spend seven, that kind of thing. Because, the bigger equipment you get, the more it's going to cost you just for that one time you're starting up your table saw. So that's what DPU is trying to avoid in incentivizing people to lower their demand. And we didn't talk about that much but there's not a whole lot you can do about it, except, don't start two high load things at once, basically, is the only thing you can do. Yes, go ahead. Yeah. Yeah.
The question was, so this is a great system, but not everybody's quite up to speed or this and capable. And we do have a lot of steps in place to start to communicate what does your load look like. We have the AMI portal. If you don't have it already, you have access to your data. You have access to your gas, water, and electricity usage data. So you can go in there and you can see what does a month look like? What does a day look like? What do your hours look like? You can't get quite as minute as that. It's a super cool. I like data, so that's super cool. But we can at least start to see where is your highest point in a day? What does that look like? It's not going to show you what's being operated, but you can go through your own daily routine. Like when I look at my usage, I can see in the morning, run on the coffee maker, maybe microwave for oatmeal. And then sometimes I come home for lunch. So there's that peak for lunch. And then I run my dishwasher and my clothing at 2 a.m. Sometimes it's regrettable. I can hear my dryer. So I can see those peaks in the middle of the night too. So you can start to see what that looks like. And you can see how much are you actually using between 5 and 11 and what is that behavior you're doing there and where can you start to shift it? Is it shifting your EV usage? Is it not starting a dishwasher right then? Because you know what you're doing between those times in your house. And just a clarification for the demand charge, it's only going to be charged once per billing cycle. So you can look at your whole month and see which day has the most usage, and that's when you'll get charged for it. It's not a daily thing. It's not. So it's only once per billing cycle. Yeah, the question or statement was kind of see if we could see it on the bill directly. What does your trending look like? And that might be possible with the new software. I'm not sure. I don't do the billing side of it. We just do bill inserts and we do the best we can with the technology we have access to. But we've had a lot of requests for could I have my usage directly on there? Or, I mean, you can see month to month your usage at the bottom of your bill, but that doesn't really tell you much, right? You just know you've spent more than last month or less than last month. But yeah, we'll have to see what the new software can let us do. Some statements to speak out to the Zoom attendees. Mr. Gibson, let me know if I misspeak for you. A lot of EV users are using them for commuting, so maybe not plugging it in and topping it off every night. Changing that habit. Maybe you're fortunate enough to have a smaller commute or a higher range vehicle where you can plug it in on the weekends or outside of the peak time and let it charge completely. And then the second comment just went out my brain.
Demand charge.
Oh, the demand charge is for the highest hour usage. So those instantaneous devices that were kind of talked about before wouldn't count. So if it's just starting up for a hot second, right, it's not going to be able to register it really like Gary's system. So it's that higher. Are you running your dishwasher, laundry, vacuum cleaner, and air conditioner because you're running all those appliances on a Saturday at 2, because that's cleaning day? That's when it's going to detect it.
Let me expand on that just a second. Yeah, so so I didn't really understand that because again, I'm not a utility electricity payer, but that makes a lot of sense because then, the question is what strategy as a consumer would you apply there? And I think that's like, you don't want to run all those things in the same hour because that's going to stack up your peak demand and you're going to get charged for that. So if you're going to vacuum the house at the same time you're doing your charging your electric vehicle, you might want to wait kind of thing. If you're concerned about that or want to reduce that peak load, or at least don't stack up too many of those things that your peak load for that hour gets too high. Yes. Oh, the question was, what kind of electric car do I have? And I have a Chevy Volt, like a 2017. It's a hybrid, so it only charges 14 kilowatt hours, and it'll go 60 miles. So where I live, I can get all the way up here and go to work, and then charge it at work, and then drive all the way home, and uh, and it works out for me. But it's yeah, 14 kilowatt hours. It's if I had a full electric car with my off-grid system, I would not be able to charge that with the 7 kW that I have. It's half my battery size, but with a 7 kW system, 7 times 5 hours of good sun, I get about 30 to 35 hours of production a day, and I don't use that much. So I can charge the car and get my batteries to 100% in a day. Um, I have not. Oh, the question is, am I thinking about using my car battery as a backup to the house because I'm off grid? And it makes a lot of sense. Yeah, I haven't really had that problem. After all the years, I've been able to dial things in enough where I probably run a generator, a propane generator that automatically kicks in when it gets below, 10%. I maybe run it 3 hours, 5 hours a year. So I'm not really thinking about backup anymore. Really with this home assistant, it's able to control my loads enough that I'm not really considering upgrading my system to a higher capacity. I'm also not really considering, using it for a backup. But I've looked into that. I do have a electric golf cart, and for many years that actually did get parked, and it would plug in to my system, and it would be in parallel to my system, and it was about a third of the capacity of the house, and it would support the whole house at night. Uh, so yeah, it was a great thing, but it's a little more complicated when you're talking about different voltages and chemistries and charge controllers, and there's a lot of diodes involved and one-way valves, and it's complicated right now. So they haven't really, I mean, as far as I understand and what I know about that technology, it's not super easy quite yet. Um, maybe they've done. I haven't really looked for the last couple of years, but I have looked into it.
All right. So if we have questions in room for our presenter, we can ask them after, but I'm going to go ahead and end the Zoom portion of this. Thank you everyone on Zoom and in the room for joining us this evening. I wanted to remind you that this talk was recorded, so it will be available on YouTube in a matter of weeks, probably 2 weeks. But yeah, thank you. I hope you drive safe tonight if you're driving from here, and I hope you have a great evening otherwise.
Yeah, thanks everybody.